Hello, this is Rohan-Paul. Very welcome to my machine learning and deep learning YouTube channel. Let's get started. So this is the second part of the previous video on applying LSTM, long short-term memory network, on historical Bitcoin prices to predict future prices. But first, the most important part, which is a disclaimer on this video. So this video and the associated code in the notebook is entirely informative. None of the content presented here constitutes a recommendation that any particular security, transaction, or investment strategy is suitable for any specific person. The video is purely for educational purpose. And Bitcoin, crypto trading, futures, stocks, and options trading involves substantial risk of loss and is not suitable for every investor. The valuation of the securities may fluctuate, and as a result, clients may lose more than their original investment. So to summarize again, this video is just for educational purpose and in no way constitutes a professional advice on Bitcoin investment or any other type of investment. First, let's quickly recap what we did in the previous video, and then we'll start off with this one. So in the previous video, this is a GitHub code that I'm referring to that was done in the previous video. So we had the historical Bitcoin prices of from 2015 10/27, that is 27th October 2015 up to 30th October 2021. And so this was the data. We had OHLC data, that is low, high, open, close, volume data, and the corresponding timestamps. So initially we downloaded the entire dataset on a per minute basis. As you can see here that for 10/27 I have one data at 04, then at 03, 02, and so on. But later I actually, okay, then the next step was to convert the time column, which was of object D type to date time D type, and then I converted these per minute data and resampled it on a daily basis. That is, the entire day's per minute data was grouped on a daily basis, and then I implemented few plots to check the correlation between the price and the data, that is on a daily, on a minute basis, on a hourly basis, on a daily basis. And then the whole data set was for the entire period, and because I had to run my LSTM model on this data set, so I had to split the data set to train and test, because like we discussed in the previous video, we can never, during the training phase, can never see the part of the data on which the model will be tested. That is, test data needs to be completely unseen during the training. So here we did the most important part, to train, test, to split the data into train and test, and we kept 70% of the data for training and 30% for testing. And then we scaled the data down with the min-max scaling. And for this LSTM, I had the look back period defined to be 5. That is, the most important architecture of this LSTM was that I'm looking back previous 5 days of data, and then I am predicting the 6th day of data. So the previous 5 days is kind of my X input, and the 6 days data is the Y, or the target variable. And this is kind of a sliding window that will slide for the entire training. That is, for each loop, the LSTM will look at the previous 5 look back period and predict the 6th day. Then the window will slide, and the immediately preceding 5 days again will be looked at, and the 6th day will be predicted. So with the help of a little function called dataset generator LSTM, I changed the dataset into this kind of shape. That is, the original training dataset needed to be split like this: train X, train Y, and then test X, test Y. So the train X is nothing, just like I mentioned, that it's a previous 5 days of look back period. And so this is the shape I had for my train X and test X. And then so this was one of the most important point, and we discussed this in detail in the previous video, that for LSTM the input data should be reshaped into a 3-dimensional tensor of samples, time steps, and features. And that's what we did, because we reshaped our original input data set into this 3-dimensional tensor, the samples being the the entire length of the data set. Timestamps for us was 5, and the features were the number of features. All right, and yeah, so I think after this we pretty much ran the entire LSTM model, and let's check the model architecture that we had. Yes, the final LSTM was a very simple one that I had one. It's a sequential API of Keras, and then I applied the LSTM layer here and the dropout of 0.02, and then another LSTM layer again, and after that another dropout layer. And with that, finally I had a dense layer, and so my model was trained. And then before finally running the model training, I also defined early stopping and checkpoint and passed these two as a callbacks to the final model training line of code as callbacks. So this was my final training line of code, regressor.feed. And then I think it took a couple of minutes to run the entire model. Let's check what we got after the entire model training was completed. Yes, so after the model was trained, I got for the entire training period of data, that is, I had data from 27th of October 2015 up to 30th October 2021. So for the entire training period, I got the predicted Bitcoin price, and this blue line was my actual ground truth, that is actual trading price of Bitcoin that was observed in the actual market. So this was a plot for my test data, and also I plotted the same graph for my training data. So here in this plot, I plotted the red line here is a predicted price of Bitcoin, and the blue line is the actual ground truth price of Bitcoin. And of course, as you can imagine, that for the training set, the two graphs almost overlaps each other because the entire training was done on this training set. But for the test data set, it is not so much in sync, which is expected. And at the end, I got RMSE, root mean squared error for test data and train data as well. For the test data, I got an RMSE of 1640.541, and for the train, I got much lesser as expected, RMSE of 937 for the train portion. All right, now that was the entire recap of our previous video. I took a slightly more longer than I thought, but anyway, so on this, now I'm going to do the next part, which is that now that I have the trained LSTM model on the historic data, I am going to predict the future 5 days, that is after 30th. So 30th November 2021 was the last historical price that we had initially. So now I'm going to go beyond 30th October 2021 to predict the future next 5 days of Bitcoin prices. Which is ultimately the target of any model training, that I have to predict the future. So let's do that. And most importantly, remember that our look back period has been defined to be 5 days. That is, I am looking back 5 days to predict the 6 days of Bitcoin prices. So here also, when I'm trying to predict the future 5 days, I have to, so for predicting the first of the future days, I will look back the previous 5 days. That is, to predict tomorrow's Bitcoin price, I have to take the historical prices of the immediately preceding last 5 days. And then to predict the, I have actually written the note here, feed into the model the past n, that is a past look back number of days values, and we get tomorrow's value as output. Then similarly, to get the day after tomorrow's value, feed the model the past n-1 number of days values along with tomorrow's value, and the model output day after tomorrow's value. So again, this is a sliding window, so we have to run a loop. But first, let's get back, let's check our actual input data. So just remember that our test X was the last 60 days of historical prices of Bitcoin. So let's check what our test X looks like. Yes, so this is our test X. and it's a three-dimensional array because we have reshaped it accordingly, because LSTM needs the three-dimensional input to be fed into its model. And now check the testx.shape. Okay, so it's 55 by 5 by 1, and so I have to take the last 5 elements from this three-dimensional tensor, and this is the code. So look back period, I'm defining it to be 5, and one second, let's zoom in a little bit. Yep, look back period is defined to be 5 because I'm looking back 5 previous days. And then in the next line, I'm making use of the Python slice notation. That is, we already know that testx.shape 0 is 55. We already checked that here. And from that, I'm deducting minus 5. I'm deducting 5, which is look back period, and then colon. So this expression will give me the last 5 days. That is the starting position from this index, whole length of the testx minus look back period, and up to the end of the array. And if you run this, I should get, yes, 551. That is, this is my input data for the forecast that I'm going to do now. So 5 by 5 by 1, and again, it's a three-dimensional, it's a 3D tensor as required by LSTM. And then in the next, I'm just going to run a loop. Actually, before running the loop, let's check if how my this whole text for the next 5 days looks like, this 3D tensor. So I'm just printing the whole tensor. So as you can see that this is a three-dimensional array, and this is each window. So each window has 5 number of data points, and each of these data points are actually the Bitcoin prices. And of course, they have been scaled down with the min-max scaler, and that's why you are seeing this kind of 0.972, etc. Because the whole prices has been scaled between 0 and 1. So this is a sliding window, and in each window I will have 5 data points or 5 price points, and based on these 5 price points, the next one will be predicted, which is the job of the LSTM model. And similarly, it will run 5 loops. Yeah. So now, basically, what all I have to do, that I already have the trained model, and that model now needs to be run 5 times for these 5 windows, and each window will have 5 immediately preceding days of Bitcoin prices. So this is my code for that. Oops, sorry. So this is a code for predicting the future 5 days. Yeah. So let's go through line by line. It's very simple, super simple code. All I'm doing, I'm just defining a variable to hold the array of the next 5 days of data, and then I'm running a single loop. That loop should run 5 times because I'm predicting future 5 days. And then in the next line, this one, I am just applying the predict function because my model has already been trained, and that trained model was saved with the at this checkpoint, that is model from saved checkpoint. So in the previous part of the notebook, we already have saved this trained model at a checkpoint, and now I'm just on that saved trained model, I'm applying predict function, and predict to that predict function, I'm passing a single input on which the predicted price will be calculated. So these I and I plus 1 with a slice notation, this is a single input data from the test X to the predict function. So the predict function with this line, predict function will give me a single scalar value for the predicted price of Bitcoin for this input data. This is the input data. And then when I get this predicted forecast price test X, that, remember, it was scaled, so I have to scale it back. That's why I'm applying inverse transform, because initially we applied min max scaler, but now I have to get it back to original actual Bitcoin price scale. Otherwise I cannot compare it with the plot or with the real price of Bitcoin. So that's why I'm applying inverse transform. And finally, this value I'm just appending to this array. And so now this array should hold all the future 5 days, because this loop was run 5 times on these data set that we defined in the previous cell, test x last 5 days, and now this should give me 5 future days of forecasted Bitcoin price data. Let's run this cell. Awesome. And 1 2 3 4, why did I get, no, yeah, I got 5 days. See, it's a 5-dimensional tensor I got. So this is the forecasted price for the 6th day. This is the forecasted price for the 6th day, means the next day. So this is the first day of the forecasted period. This is the second day price of the forecasted period. This is the third day price of the forecasted period, and so on. So with that, my job is pretty much done now, but now I am just going to, for the final representation of data, I'm going to do a plotting with the actual data of the entire ground truth trading period, and also the predicted data for the entire ground truth trading period, and also these 5 forecasted data. So for that, let's first do some little data processing. These predicted 5 days forecasted price test, this is actually, I have to turn it to an np.array for easier calculation, and let's check the shape. Yeah, so as expected, this is a 5 by 1 by 1 data matrix, and remember, this is just for the future 5 days of forecast period, but we also have the entire previous days of a predicted price data of Bitcoin, that is for the entire ground truth period from 2015 till 2021. We have the ground truth actual trading days, actual trading prices, but also we have the predicted prices, and that variable is this one. Predicted BTC price test data. This was a prediction for the entire ground truth trading period. Let's check its shape as well. Yeah, this is 55 by 1, and I have to actually combine both of them together. But before that, let's check their actual form. I think they are in a tensor form, 3D. Yes, they are in a this is a 2-dimensional tensor, and this should be 3-dimensional tensors. Yes, so let's flatten them just to make the calculation a little bit easier. I'm just flattening these predicted 5 days first. Not shape, just print the entire data after flattening. Yes, it got flattened, and I have to do the same for this one as well. Predicted BTC price test data, which was for the entire actual trading days. Awesome. These also got flattened. Fantastic. Now I have to combine them. I'm just defining a variable to hold the combined or concatenated these two arrays. Predicted BTC test concatenated, and I'm using np.concatenate. To this, I will pass just this array and also this array, and then I can print this array. Why did it happen? Only integer scalar arrays can be converted to a scalar index. Oh yes, I have to pass the arguments to np.concatenate in a tuple format. Yes, it should work. Run this cell. Awesome. So now they have been concatenated. Let's check their shape. The shape should be 60 number of samples. Predicted BTC price concatenated.shap. Yes, So I have just now 60 scalar values in the array, and now I am ready to plot it. So this will be my code for plotting. Again, just super simple. Defining the figure size, and then I'm plotting the predicted BTC test concatenated, and also test actual. Test actual is my actual ground truth data for the same period. So remember, this test actual will have 5 less number of days, because the actual number of trading data ended on 30th October 2021, but predicted BTC test concatenated, this variable has the actual trading days plus the 5 forecasted days. So let's run this cell. Beautiful. So this is the final plot. So the blue line is actual trading days, and the red line is a predicted from the LSTM model, predicted prices of Bitcoin. And up to this day, that is up to 30th October 2021, I have both the predicted test data and the actual test data on the ground, because this is the period for which I have the actual ground truth. Beyond this period, I have only the forecasted price of Bitcoin, but no actual data, because this is a completely forecasted data. We don't have the trading data at all yet during this period. So yeah, that pretty much wraps up this video. And once again, I am going to upload videos on the subject of TensorFlow and PyTorch in my channel pretty frequently. So if you have not subscribed yet, do subscribe. And if you like this video, smash the like button. See you in the next video.